Friends, in this video we are detailedly study about what do we mean by the closed loop control of drive. So in that particular we want to understand the detailed concept of speed control loop with inner loop of current control. So let's begin. Friends, this will be the very important concept of electrical drive, because the name of the concept that will be called it as the closed loop control of your electrical drive. So this will be the first part, and the second part, that is the speed control loop with inner loop of current control. So first of all we can understand what will be the concept of the closed loop control of drive. Okay, basically in a control system, that is we are using two types of systems are there. Okay, so in a control system we are using the two types of systems are there. The first system is called as the open loop control system, and the second type of system is called as a closed loop control system, obviously. So according to the university syllabus we want to understand uh, the different closed loop control of your electrical drive. So friends, as we know that drive is a system employed for motion control, and if we are using electrical motors for the motion control, then it is called as electrical drive. So in concern with electrical drive we want to understand the closed loop control of drive. But before we starting to understanding, first of all we have to know the basic fundamental thing in concern with the open loop control and closed loop control. So friends, in a open loop control system, the output has no effect on the input. So friends, in concern with the open loop control system, we are having the input. This is called as input, and this will be the output. We are considered as an open loop system. This is called as the output. So obviously from input to output. So in open loop control system, the output has no effect on a input. So friends, the output doesn't have effect on your input, means the output is totally independent on your input. So such kind of system is called as the open loop system. So the example for the open loop system, that is a phenomena, that is the controlling phenomena, obviously is independent of its output. On the other hand, means in concern with the closed loop control system, this will be the closed loop control system, that will be the input, this will be the output. So obviously this loop is called as a feedback loop. So in concern with the closed loop control system, obviously much more advanced and scientific, because there is a effect of the output, that is the effect of the output is basically dependent on your input, because we are connecting one link which is called as the feedback link in concern with the closed loop control system. So now the loop is closed here, so that's why such kind of system is called as a closed loop control of your electrical drive. So obviously due to the closed loop control of electrical drive, it will possesses various advantage. Such advantage are the in concern with the increasing the efficiency, increasing the various values, and obviously such kind of closed loop control system is very scientific and useful for the n number of application, because the output is basically the value of the input is effect of that particular output, because that the particular output has the effect of that particular input. So such kind of system is called as a closed loop control of your electrical drive. So friends, let's we can start to understand in detail concept of the closed loop control system. So obviously in a closed loop system, the output of the system is feedback to the input, as we have seen. So this will be the, again I can draw this system because this will be the very important concept. This will be the input, this will be the output. So in concern with open loop system, there should be no dependency on each other, but in concern with the closed loop control system, we are using the element which is called as the feedback. So due to that, such a system is a feedback control system also. Sometimes we called it as a feedback control system. So obviously the closed loop system controls the electrical drive, and the system is self-adjusted. So in concern with, obviously friends, in concern with electrical drive, now we are considering the example, and that the example of electrical drive, basically in concern with electrical drive, as we have the fundamental thing of understanding. So that is the fundamental thing of understanding, that we are using electrical drive. So we have the different blocks of your electrical drive. Such blocks are called as the first block of your electrical drive. Now I can draw here a block diagram. This is the first block diagram of your source. Second block of your electrical drive, which is called as power modulator. Then third block, which is called as motor. Fourth block, which is called as load. So in concern with motor load combination, we are using some of the mechanism which is called as sensors. And from sensors, we are getting the value of the control unit. This is called as control unit. From control unit, we are giving the command to the power modulator, and we are giving some of the input command to your control unit. So obviously in concern with the electrical drive, this will be the block diagram of your electrical drive. So in concern with electrical drives block diagram, we can understand the electrical drive will obviously receive, because this will be the input of your electrical drive, and this will be the output, which is called as load. So for the sake of that particular output, we can take the sensing of motor load combination, and that the input is given to your control unit, and now your control unit will giving signal to your power modulator. Means we are taking the output reference for the understanding of the controlling of your electrical drives parameters. So such kind of system is called as a closed loop control system of your electrical drive. So obviously we can understand what is the use of feedback loop. So obviously the feedback loops in electrical drive may be provided to satisfy the following requirements. So the feedback loop, that is a feedback loop which will call it as the sensing unit and control unit. Now we call it as the feedback loop of your electrical drive. So this feedback loop obviously satisfy the following requirements. So the first requirement is the enhancement of the speed response. So the first advantage is that enhancement of the speed response. The second advantage is that or the requirement to increase the steady state accuracy, means due to the presence of that particular closed loop speed control of your electrical drive, the accuracy that is called as the steady state accuracy is obviously more in concern with that particular closed loop control system. And the third very important requirement, in concern with the protection, because in concern with that particular feedback control loop system or the closed loop speed control system, we are getting the protection for your devices. So these are the various requirements that are in concern with the your closed loop control system thing. So obviously friends, in concern with the what are the different main parts of the closed loop system. So the main parts of the closed loop system are obviously the controller that we are using. I can tell that this will be the controller that will be very useful. That will be the control unit is very useful for your system. Then converter is called as a power modulator that we are using in power modulator, different types of converters. Such converters are maybe rectifier, such converters may be your inverter, such converters may be your chopper or AC regulator or a cycloconverter. So this will be the very important parts of your closed loop control system. Then the current limiter is very important part, and basically that the current loop control scheme will be applicable in concern with the power modulator circuit or the motor circuit itself. Okay, then the current sensor. So obviously this will be the current sensor, that is a current sensing unit. So these are the various parts of your closed loop control system. So let's start in detail about what do you mean by the system, that is by taking one of the example, and that the example is called as the speed control loop with inner loop of current control. Okay, so friends, what will be the basic concept behind this closed loop speed control technology? I can tell you friends, this is one of the speed control technique. This is a speed control loop. Okay, so we want to control speed of your motor. Okay, but as we have the basic concept of electrical engineering, we have the different parameters. We can start the speed control loop with a inner loop of current control. So basically, friends, in concern with that particular speed control technique, we want to understand first of all what will be the concept of the speed control loop. So friends, as we have in an industry, there are different types of motors are used for a particular applications. So as we know that we are electrical engineering student, and we have the basic concept of the different speed control methods for a different motors. So basically, in concern with the speed control loop with the inner loop of current control, we want to control what will be the basic fundamental thing behind that particular technique. We want to control the speed of your motor, but for the speed control of your motor, we are using technology, or by using a method, that the method which is called as inner loop of current control. So what do you mean by the inner loop current control? We can understand, and we can get the detailed explanation about the speed control loop in which we are using the loop control technique. Okay, so friends, speed control loops are perhaps the most widely used feedback loops for your drives. So obviously such kind of technique is mostly widely used for your feedback loops of your drives. So as shown in figure, friends, we are having two control loops. So we can see the diagram and understand the concept. So as we have the diagram, we can understand. So this will be the diagram of your closed loop speed control technique. So in that particular diagram, we are having a two loop, friends. So this will be, I can write this will be as a first loop. This will be the first loop. We called it as such a first loop, which called it as a basically inner current control, current control loop. And friends, we are having a second loop. Now I can write this second loop. So such kind of loop is called as the outer speed control loop. So this is called as inner blue color, yellow color lines, inner loop control. Okay, and this will be the outer loop speed control. Okay, so let's begin to start. So basically, this will be the first, that is inner current loop, and second it is called as the outer speed loop. So obviously value in concern with the inner current control loop, the limits the converter and motor current or motor torque below its safe limit. So obviously what will be the purpose of that particular inner current control loop? So we want to control the motor current and motor torque below its safe limit. That will be the first part. And in some schemes, the current is current directly, in other it may be controlled indirectly. So obviously in some of the technique we are controlling the current that is directly, but in some of the technique we are controlling such kind of current indirectly. So this will be the very important. So for example, in concern with the variable frequency induction motor drives, the current is controlled by the controlling of the slip, because we want to control the slip, but we are using the controlling of that particular current by means of the controlling of slip. So this will be the indirect method for the controlling of your current. So this will be the one of the example for your speed control loop with inner loop of current control. So friends, let's we can understand what will be the concept in concern with that. So friends, as we have the loop, so this will be the first loop. I can write down, it will be a first loop, that will be the first loop, and that will be the second loop. So the first loop will consist of, this is called as, this will be called as the inner current control loop. And the second one, which is called as, this will be the second one, this will be the second loop. Now we call it as the second loop, outer speed control. So friends, now we can understand the concept of the outer current loop, and in concern with that, for the controlling of your speed, so means this is your the second loop which is used for your speed control. And as we have the fundamental concept, if you want to control the speed of your motor, obviously we want to control the current. So in concern with the that type of speed control technique, we want to understand first of all the current control loop. So friends, in current control loop, now we can clear this and understand the concept. Suppose friends, we want to control a speed of your motor. So as we have this with the different blocks of your motor, so now we can consider this will be the basically this will be the block which is called as the power modulator. This will be the controller block. This is the input, that is the controller line input, that is will require the input to that particular controller circuit, and we are having the value of the supply, that is the supply which will be given to your system. So this will be the another representation of your electrical drive, so in which we are having different types of power modulators. This is power modulator, this is motor, this is load, this will be the sensing part, this will be the sensor, this will be the sensor. Now this sensing part will be given to your controller. So this controller will having the part of the current limiter circuit, we are having the controller circuit, and from controller circuit now we are giving to the supply to your power modulator. This will be the another representation of your block diagram of your electrical drive. So for the understanding of the concept of the speed control by the inner loop control, we have to understand the first loop. First of all, this first loop. So this first loop is basically called as the inner current controls. So in that particular loop, we are applying the current to that particular circuit. So obviously input current will be controlled by this current controller. So the input of that particular current controller will be given to your converter circuit, so that the converter circuit will convert that particular value of the current, and depending upon the converter value of your current, depending upon your the reference value of your current, because current sensor will sense the value of the current, so that the current value is given to your summing point. This will be the summing point, and from the summing point we are given the input to your current controller. So the current controller will convert that value in concern with the power modulator firing angle or the duty ratio of that particular converter circuit, and now this the input is given to your motor. Okay, so obviously in concern with that particular motor we are controlling the current. So this will be the first loop. Okay, then the second loop, which is called as in concern with the speed. Now we are taking one of the example. Obviously if you want to control in concern with the electrical machine, as we know that in concern with the DC machine or in concern with the AC machine, we are consider the example of the DC machine. So as we know that the current is the current value. If you want to control the speed of your motor, we want to control obviously the value of the current. So depending upon the value of the current, the speed of your motor will be increase or decrease. So if you want to control the speed of your motor, obviously we want to control first of all its value of current. So if you want the value of the controlling of your current, we want to understand the current control loop. So this will be the inner part of your speed control technique, that is called as inner part. And then the second part is called as the outer part. Why it is called as outer part? Because we want to control the speed of your motor, that is outer part. So in concern with outer part, we are using the different sensing, that is sensing which is called as the sensor. That type of sensor is called as the speed sensor of your circuit. This is called as the speed sensor of your circuit. And now this speed sensing part is given to your input or the summing point of your speed, because in that particular speed we are having the value of the reference speed. This will be the reference speed, means the omega m star. This is the value of the reference speed, and this will be the value of the speed which will be sensed by your sensor. This will be the value of the speed. So depending upon the reference speed and the sense speed by your motor load combination, a value of the change in speed, that is the del omega m, is generated, and this value now we are given to your speed controller. So in speed control loop, we are using maybe different types of speed control technique. So basically, if the motor is DC, suppose we are taking the armature voltage or field flux speed control technique. So obviously, in concern with armature voltage and field flux control technique, we have to control, or we have to use one block which is called as current limiter block. So in which we can control first of all the value of the current. So if we are changing the value of the current, so obviously depending upon the value of the change in current, obviously the speed of your motor will be the increase or decrease. So such kind of technique is called as the closed loop speed control technique of your electrical drive. So we can understand the detailed explanation again. So we have the detailed explanation with us. So obviously, as increase in reference speed, suppose we are using the reference speed that is increasing, the positive error, that is the delta omega m. So the speed error is processed through the speed controller applied to a current limiter, which saturates even for a small speed error. Consequently, the limiter sets a current reference to the inner current control loop at a value corresponding to the maximum allowable current. So drive will accelerates at the maximum allowable current, and in the same cases at the maximum torque, because as we know that the current is directly proportional to torque. If you want to get the value of the maximum value of current, we are getting the value of maximum torque. When close to the desired speed, the limiter desaturates and steady state is reached at the desired speed with some steady state error, and at a current for which motor torque is equal to the load torque. So obviously, as we have the steady state equation, that is motor torque is equal to the load torque. So obviously this load torque is again dependent on the current, so that's why we called it as the current torque or the load torque. So torque is dependent on current. If you want to control the value of the torque, you have to control the value of the current, and that will be done with the help of the inner current control loop. So in diagram, as we seen that, again I can clear and again I can show you. So if you want to control the speed of your motor, obviously you have to control first of all that particular current. You have to control first of all that particular current by means, if the value of the current, that is the reference value is of current, that is omega m, this will be the actual sensing value. So due to that, a del omega m, that is the error value of your speed, will be generated, and depending upon that the error value of speed will be given to your speed controller, and that will be limits the value of current. So this will be the very important thing in concern with the closed loop speed control scheme. And obviously depending upon the value of the current limiter, as we have the relation, if we are controlling the speed, if we are controlling the current of that particular motor, obviously we can indirectly control the speed of your motor by means of that particular signal. So this will be the basic idea behind that particular technology. Okay, so now again we can move towards the next thing. When the value of the decreased speed produces a negative speed error, so obviously current limiter saturates and set the current reference for inner current loop at a value corresponding to the maximum allowable current. Means if you want to get the maximum allowable current, so obviously decrease in speed. So consequently the drive will deaccelerates or decelerates in braking mode at a maximum allowable current. When close to the required speed, current limiter desaturates. Obviously the operation is transferred to the braking to the motoring mode. So the drive then settles at a desired speed and a current for which motor torque equals to the load torque. Again we are getting the steady state value, that is load torque is equal to motor torque or motor torque is equal to load torque. So in those drives where the current, that is I, doesn't have to reserve for braking operation, current limiter will have the input output characteristics as shown. So in the drives the current doesn't have reverse for braking operation. Suppose the current will operate in only first direction, so that will be the symbolical representation of the input output characteristics of that particular inner current control loop, and such kind of characteristics we are using in a closed loop speed control of your electrical drive. So friends, again we can take some of the very important thing, and that the some of the important thing is called as, in those drives applications where the load torque will be able to provide the enough deaccelerating or decelerating torque, electric braking are not to be used. So friends, when the decelerating torque will be provided, so obviously that time we are not using the electrical braking. So obviously in concern with that particular control technique, we are using various types of controller. So such controllers are maybe called as proportional and integral controller, proportional and derivative controller, or proportional, integral and derivative type of controller for the speed control technique. So depending upon the steady state accuracy and the transient response requirement, because depending upon the steady state accuracy and transient response requirement, we are using, whether we are using proportional and integral type of controller, whether we are using the proportional and derivative type of controller, or whether we are using proportional, integral and derivative type of controller into your closed loop speed control scheme. So this will be the explanation in concern with your closed loop speed control of electrical drive in concern with the basically inner current control loop. So friends, now we are taking for your understanding one example. Suppose your speed of your motor will be, now it will be 1500 rpm, that will be the rated speed. Suppose we are, first of all we can take one of the example for your understanding. So suppose we are taking the example, the rated speed of your motor, maybe rated speed of your motor will be 1500 rpm. Okay, now we want to control that particular, this will be the rated speed, but due to some of the condition, the speed of your motor now it will be reduced to a 1400 rpm. But now we want to control again that particular speed control of your motor. Now we want to control that the 1400 to again 1500 rpm. Okay, so what will be the technique? Suppose this will be the motor which will having suppose this will be the DC motor, we are considering it as DC motor, 1500 rpm, the rated operation, but due to the some of the failure, the speed of your motor will be the 1400 rpm. Okay, but now we want to again control that particular motor to a 1500 rpm, then what will happen basically in concern with that system? So the speed that will be basically sensed by the speed sensor, because now the operation is changed, because previously the value of the speed is 1500, but now the value of the speed is 1400 rpm. Okay, so at the time of the 1500 rpm, the value of the current, that is the rated value of current, may be a 5 ampere. But when the speed is reduced, that is 1400 rpm, the current is also reduced to the 4 ampere. Suppose we are taking one of the example. So now we want to change the speed of motor to the 1400 to the 1500. We want to add, that is 1 ampere current into that particular circuit. So basically this speed sensor will sense the value of speed obviously, and it will given, that is the, we want to control speed control, that is called as the 1500 rpm. So we want to give the reference speed, that is we want to control, that is the 1500 rpm. So this will be the 1400 rpm speed. Yeah. Now the reference, that is the change in speed, so this is called as the change in speed. So obviously 1500 minus 1400, so it will changes, it's 100 rpm, means if you want to control the speed, means we want to add some, that is the error value is negative, means obviously you want to add the value of the 100 rpm speed into that particular motor. So for the sake of the increasing value of the speed, obviously in concern with the DC drive or DC drive, as we have, if you want to control speed of your motor, we want to control this current, because if we are changing the value of the current, or changing the value, that is the value in concern with the increase and decreasing value of current, the speed of your motor will be changed. So for the sake of that, now we want to control a speed up to the 1500 rpm. Obviously we are having the value of the current. So now this current sensor, previously the value of motor is 5 ampere, but due to the sum of the change in speed, now the value of the current is now 4 ampere. So this current sensor will senses the value of current, that is 4 ampere, and that the input of that particular current will be given to your summing point. So this is the value of the 4 ampere. But Current reference means what is the change in value, because we want to control the at the value of the 1500 rpm, so we want to add the value of the current, that is obviously the reference value is 5 ampere of current, so the current limiter value means we want to add 1 ampere current into that particular circuit. So the value of the current limiter circuit is that it will be used to depending upon the value of the system. So this current loop will control the value of current, means what will be the control the value of current? The value of current is reduced, that is 4 ampere. So in current controller there are different memory mapping is there, so this current controller will increase, that is 4 ampere to the 5 ampere current, and now this 5 ampere current is going to your converter circuit. So if the depending upon the type of supply, now we are consider this will be the converter of the rectifier, or we considered as a chopper circuit, so that the converter chopper will convert that the 5 ampere current into the desired its the duty cycle. If the converter is the rectifier circuit, so depending upon the value of the current, the converter circuit will change its firing angle, and that the value of the firing angle is given to your motor. So by the changing of the firing angle of your motor means by the changing of the value of the current, obviously the motor speed will be reaches to the 1500 rpm. Okay, so this will be the in concern with the closed loop speed control scheme for the inner current control loop. So in concern with that, if it is a DC motor, we are using some of the speed controller technique, so that the speed controller technique may be armature voltage or field flux, so it will be depending upon your requirement. So obviously, so this will be the example for and detailed understanding of the closed loop speed control scheme for your inner current control loop of your electrical drive. So friends, this will be, I think everyone has got the clear idea in concern with the closed loop speed control scheme. So this will be the detailed explanation of your system. Thank you.